Hello. In this video, we are going to study how to represent images using binary. First of all, we need to know there are two types of images, the raster image and the vector graphics. For the raster graphics, the image information is stored on a pixel by pixel basis. So in the raster images, we have a lot of pixels, and for one pixel, it's actually a dot, a small dot, and the file formats like BMP, GIF, JPEG are all raster graphics. For the vector graphics, the image is described by a group of lines and the geometric shapes. It's not described by the pixels. So it includes a series of commands that describe a line's direction, thickness, and colors. The basic raster graphics format is the bitmap, or BMP. For the bitmap images, it's a matrix of dots, which is called pixels. So a bitmap image including a lot of pixels. And the number of pixels is called resolution. For example, a bitmap of black white image, meaning that the image is divided into squares according to its resolution. And the record white spot as 1 and the black spot as 0. So in this image, it only has two colors, black and white. So it is quite easy to represent the image by using the binary, because for each of the pixel, we can use one bit to represent the color. So this is the original picture, and it is the black-white image. And if we zoom into the image, we can see a lot of pixels, and some of the pixels are white, and some of the pixels are black. So in this case, we can use 1 to represent the white and 0 to represent the black. And then we can store all these 1s and 0s in a file. It's called the bitmap file. Of course, we also need to represent color images. And the color is the perception of the frequencies of light that reach the retinas of our eyes. And there are 3 different colors called the primary color. That's because retinas have 3 types of color photoreceptor cone cells that corresponding to the color of red, green, and blue. So the red, green, and blue are called primary color. All the other colors can be represented by these 3 primary color. And we call this color RGB color because it's composed of red, green, and blue. So we use 3 different numbers, R, G, and B, to indicate the relative contribution of each of these 3 primary colors. The next concept is called color depth. It is the amount of data that is used to represent a color, like how many bits you use to represent the color. For example, if we use 9 bits to represent a color, so for each of the primary color, we are going to have 3 bits. So because 3 bits can represent 8 different things, so for each of the color, we can have 8 different values. So if we have 24 bits to represent a color, and for each of the primary color, we can have 8 bits. And this 24 bits color depth is called the true color. So if we have 8 bits to represent one primary color, that color can have 256 different values. So if we use the true color to represent the color, and each of the primary color can have 256 different colors, which means the value will be between 0 and 255. So 0 means no color. 255 means the full color. So if red equals to 0, that means in this color it has no red. If red is 255, it means it has full red. For example, if an RGB color is 255, 255, and 0, it means it maximizes the contribution of red and green and minimizes the contribution of blue, so which is actually yellow. So this is called a 3-dimensional color space. So we have red, blue, and green. So this vertex means black. It means that we have 0 red, 0 green, and 0 blue. So it is black. This vertex is white. It means we have full blue, full red, and full green. So here shows you some of the typical colors by using the RGB representation. So if we use hexadecimal to represent this RGB, it will be 6 numbers and 2 numbers for one color. So here shows you some different colors. So if we change any of the 3 primary colors, the color itself will also be changed. So color is a combination, and each dimension has 256 different choices. So in total, we have this number of possible different colors. So for a raster image, we can use a collection of individual dots to represent the image. And for each of the dots, we call it a pixel. And we can use the RGB color to represent the color of the dot. And the number of pixels used in the image is called the resolution of the image. So this shows you a picture with few number of pixels. As you can see from the image, the quality of the image is not very good because the resolution of the image is very low. If we increase the resolution, we can clearly see that the quality of the image has been improved significantly. So for a raster image, the resolution is an important factor of the quality of the image. And also the color depth is also an important factor. So the resolution is the key parameter for graphics. So we have the screen resolution and also the image resolution. So screen resolution means the pixels on the screen. And the image resolution means the pixels on the image. If you have an image, you can open the property of the file and it will show you the resolution. Of course, we cannot display this huge image on a small screen. So in order to show a large resolution image, you have to have a large resolution screen. So in the resolution 800 by 600, RGB true color image needs this number of storage because we have 800 times 600 pixels, and for each of the pixel, it has 3 primary colors, and for each of the color, it needs 8 bits because this is a true color image, meaning that for each of the primary color, we're going to use 1 byte, which is 8 bits, to represent the color. So in total, we need 1.4 megabytes of the storage. So if we increase the resolution to 1024 by 768, we need 2.25 megabytes. And for the image of 1280 by 1024, it needs 3.75 megabytes. For a 5 megapixel camera, it creates pictures of 2576 by 1932 resolution. So each of this picture will need about 15 megabytes. Nowadays, we often hear something like 720p or 1080p or 4K. So all of them are talking about the resolution. 720p means the resolution is 1280 times 720 pixels. And 1080p means the resolution is 1920 times 1080. And 4K means the resolution is 1496 times 2160. So all this means the resolution of the video. Here are some typical raster image formats, like the bitmap contains the pixel color values of the image from left to right and from top to bottom. And the GIF format, so each of the image is made up of only 256 colors. So the color depth of the GIF is pretty small. JPEG is a compressed format of the raster image. PNG is like the GIF but achieves greater compression with wider range of color depths. The next type of the graphics is called the vector graphics. It's a format that describes an image in terms of lines and geometric shapes. So a vector graphic is a series of commands that describe a line's direction, thickness, and color. For example, in this graphic, we have two shapes. One is the line from x1, y1 point to x2, y2 point with the color of this color. And another is a circle with the center from x, y with the radius r and the color of this color. So this shows you how to describe a vector graphic. So the file size tend to be smaller because we are not using the pixels to describe the image. We're using some mathematical formulas to describe the image. So the good side is that vector graphics can be resized mathematically and unrestricted. So it is easy to reset the image because it's a mathematical formula. For example, you have a square, so it's quite easy to make the square larger by changing the width and the height of the square. But the bad side is that for the vector graphics are not good for representing real-world images. And another bad side is that it needs CPU calculations because it's mathematical formulas. So you have to use the CPU to calculate the formulas so that you can show the image. So this is a comparison of the vector graphic and bitmap graphic. So the left side is a vector graphic and the right side is a bitmap. As you can see, the vector graphic cannot show too much details because it cannot show the small point of the image. Before discussing how to represent video, let's look at what is a video. A video is actually continuously displaying a series of images to create an animation. Because the human eyes have 0.1 second vision delay, so that we can see the continuously changing video. Let's look at two examples. In the first example, we are going to move the ball to the goal every 0.5 seconds. So you can clearly see the position of the ball is changing. But this is definitely not a good video. This is the second example. As you can see, the position of the ball is changing smoothly, so this is the good video. The only difference is that for the second video, the position of the ball will change every 0.08 seconds, so that we can feel it is continuously changing. So that is how we make a video. So a video consists of a sequence of pictures or frames. For every of the picture, we call it a frame. So fast and continuous move of the frames can create a video. Just like the example showed in the previous slide, we change the pictures rapidly so that we can create a video. So FPS is an important feature for us to describe the quality of the video. FPS means frames per second. It means for 1 second, how many pictures you have. So 16 FPS gives a satisfiable feeling. So if you have a video, you must have more than 16 frames per second. If the frame rate is less than 16, you can feel the video is not smooth. But for video, it needs huge storage. And the storage is decided by the frame size, the FPS, and the video length. For example, you have this 600 times 400 resolution video. The length of the video is 1 minute. So you need this size of storage. So this is the resolution of one image, one frame. 1 pixel needs 3 bytes, and 60 means 60 seconds. And for 1 second, you have 16 frames. So this will be the size of your video. So if the video really takes this much of the storage space, it's going to occupy our hard drive. So we need something to reduce the storage of the video and the images. So we call it codec. It consists of a compressor and decompressor. So we use a compressor to compress the video, and we use a decompressor to recover the video. But in the video is not only including the images, It also including the audio, sometimes different audios, and subtitles, and some keyframes, like the fast forward and fast backward. So it is very necessary to design the data compression algorithm to reduce the storage size.